Okay, so in the last video we defined what a set is, we talked about members and elements of a set, and things like that. So now in this video we're going to start talking about describing sets. So there's a couple common ways that we'll start talking about now. So in this video we're going to start talking about the listing method. So it's pretty much exactly what it sounds like. You just take all the elements or the members of a set and you literally list them out. Okay, but you do want to be careful though, because the thing you got to remember is that when you use the listing method, okay, basically you take all the members or the elements, you list them, separate each item or separate each member with a comma, but make sure that you enclose the list in curly braces like this. Okay, so start the list with the open curly brace like this, and then end it with this. Okay, so for example, remember in the last video we talked about the set of markers that I'm holding in my hand. So we have a blue, a red, and a green marker, right? So if we want to write that set down, that'll be our example 1 here. So example 1 of using the listing method, if we wanted to write down or list out the set of markers in my hand, so blue, red, green, so we would start with an open curly brace like that, and then we just write out these colors, blue, comma, red, comma, green, and then close curly brace. Okay? And maybe we can make that look a little prettier. So it does take some practice to make those look, I don't know, pretty or cute or whatever. But anyway, so be very careful. You got to use the curly braces, so don't use square brackets like that. Don't use the curvy parentheses like that. Those are not correct. It's not correct to use those. So make sure you use curly braces. Okay. Now another thing to point out here is that we listed these the order I was holding them from left to right, blue, red, green, right? But we don't have to list them in that specific order. So when you use the listing method, it doesn't matter what order you list these in. Okay, so it's going to be the exact same thing as if we said, so we could also say red, blue, green, for example. So we could say red, blue, green. Okay. Yikes. Okay. Yeah, that close curly brace is pretty hard there, for me anyway. So blue, red, green, it's the exact same thing as saying red, blue, green, because again, the order does not matter. Okay, it doesn't matter what order you list these in. So actually what we say then is that these two sets are equal. We put an equal sign in between them like this. And that kind of leads into another definition here. So two sets are equal two sets are equal if they have the same elements or members. Remember, those mean exactly the same thing. Okay, so two sets are equal if they have the same elements. So here, blue, red, green, and red, blue, green, they're exactly the same elements, just listed in a different order. But remember, it doesn't matter what order you list them in. Okay, it's the exact same thing. So these two sets are equal, and we denote it with, typical equal sign, just like we'd expect. So nothing really too crazy happening here. Relatively simple definition, but pretty important. So two sets are equal if they have the same elements. And if they have different elements, then they're not equal. And we'll talk a little more about things like that in a later video. But anyway, so remember when we talked about sets in a mathematical context, we're really talking about sets of numbers. That's typically what we want. So let's do another example with sets of numbers, and then we'll talk about some related notation. Okay, so this is example 1 with the markers I was holding earlier. Now example 2, let's come up here and look at that. So example 2, so let's say we have the set, I want to call the set A. So A equals 2, 4, 6, 8. Okay, so again, open curly brace, then list out these elements with, they're separated by commas. Okay, so remember, separate each one with a comma. And then close curly brace here, which maybe I could have made better, but it's good enough, I guess. I don't know. Anyway, and I'm calling the set A. So, okay, the set A is going to equal, defining the set to be this guy here. It is 2, 4, 6, 8. Okay, now that's basically just another example of doing the listing method, where we literally take the elements or members of a set and just literally list them out. But remember, you got to have these curly braces around them. Okay, so it's not correct to use brackets. It's not correct to use parentheses. It's also not correct to have nothing. Okay, so if we were just to say this, this is not a set. Okay, this is really, it's not really clear what's going on here. Okay, but if we want to be clear that we're talking about a set and we're using the listing method, we have to have these curly braces here. Okay, so they're really not optional. They have to be there. So be very careful about that. kind of notation there. Okay, so speaking of notation, there's something else to talk about here. So we're talking a little bit about members or elements of a set. So let's look at the members and elements in this set here. So notice the number 2 is in this set A, right? So this whole thing we're calling the set A, and we see the number 2 is in there. So what we could say is that 2 is an element of A. Okay, so this thing right here, let's zoom in a little bit in this area. So this thing right here, it's not the letter E, be careful about that. It's kind of like the business end of a fork. So if you take a forky looking thing and just take off the handle, then you're just left with the business end of the fork. So that's kind of what that is here. So that's basically just read element of. So what we say is 2 is an element of A. Because we see, if we look at the set A, all the elements are listed out, 2, 4, 6, 8. We see that 2 is in the set, so 2 is an element of A. What else do we see? Do we see anything that's not in the set? Yeah, there's a lot of stuff not in the set, so we could say 3 is not an element of A. So the way we describe that, or the way we denote that, is with this business end of a fork again, but then we put a slash through it. Okay, so we put this tilted slash through it, where it could tilt this way or it could tilt the other way, it doesn't really matter. But make sure you just put one slash through it, because that's all you really need. Okay, so 2 is an element of the set A, because we see 2 is sitting right there in the set A, but 3 is not in A, because here A is only the numbers 2, 4, 6, and 8. Okay, so 3 is not a member, is not an element of the set A. Okay. What else is in A? Well, 4, for example, right? 4 is an element of A. Okay. What about negative 12? Negative 12 is not an element of A. Okay. So remember, just this business end of a fork means element of, so this thing over here is an element of A. This thing over here is an element of A. Business end of a fork with a slash through it, not an element of A. Okay. Now we can also have it sort of facing the other way, but you got to be careful. So you can also say this. You could say, whoops. So if you wanted to switch this around for whatever reason, then you could say A, but then your business end of a fork has to point the other way. Okay. So for example, like this. So then what you could say is A contains the element 2, or you could say A contains the element 4 or has the element 4, things like that. So make sure that you know, the business end of a fork, okay, the prongs of the fork have to point towards the set, okay, and this part here has to point towards the member, the element, or the number, whatever. Okay, and of course we could also have this one going the other way. So we could say A does not contain 3, and we could say A does not contain negative 12. Okay. So just be careful about that. It's really not correct to say this. Okay, this is very bad because this is pointing the wrong way, right? So remember, it has to be like this or like this. Okay, so the prongs, the pointy end of the fork has to face towards the set. Okay, so not like that, don't do that. That's bad. Okay. Anyway, that's 2 examples with the listing method and some related notation here. Okay, so this notation here, this doesn't just apply to the listing method, this just applies to all sets and elements in general. Okay, so no matter how you're describing a set, whether it's the listing method or in the next video we'll start talking about the set builder method. Okay, whether you're using that or the set builder or anything else really, just when you're talking about elements and sets, you have this sort of notation here with this business end of a fork to mean element of, 2 is an element of A, 4 is an element of A. A contains the element 2, or A has the element 4, things like that. Or you also have this business end of a fork with a slash through it, this way or that way. So 3 is not an element of A, negative 12 is not in the set A. A does not contain 3, A does not contain negative 12. Okay, so you have this notation here no matter how you're describing your set. Anyway, that's a couple examples with the listing method and some important notation there. So in the next video, we'll talk about the set builder method for describing sets.